My name's Dan Gilliland, and this is my glider that I named Breeze. So the list of the requirements are the first one: the maximum the glider can't be more than 16 inches wide or 16 inches long. So to me, the first thing that jumped out at me about that was you can't just have these, 10-foot wingspan. So I'm gonna have to do something creative to get these wings to be able to produce enough lift to get them to do what I want them to do. And then the next one must be hand thrown. So obviously no electric propulsion systems on it, no hooks to throw it with a slingshot. And that I must be able to actually grab onto it somewhere, so no sense carving off a bunch of wood if I'm not going to be able to grab onto it with my hand and throw it well. Must be able to fly at least 20 feet in one direction. So for that, obviously you're going to want stability in terms of yaw, roll, and pitch. Don't want it doing any of those too aggressively. Obviously it'll turn off or hit the ground or whatever before you hit 20 feet. And it must be able to make the flight and land without breaking apart. So for me it was obviously be able to create it strong enough without making it too heavy so it doesn't just break apart once it impacts the ground. For the design process, the wing shape is going to be tapered versus rectangular. Rectangular is obviously easier to manufacture, but it's also more inefficient, less stable, more induced drag. And the tapered obviously has less induced drag, which gives you more endurance, also a higher aspect ratio, and it's more stable due to you got a twisting effect, and the most twisting you're going to get is at the longest part of the cord, whereas in rectangle you've got the same cord length the entire way, and on tapered it's right at the root. So you're just not going to have as you're going to have more stiffness when it comes to torsion, which is going to help your stability. For adhesives, it's either going to be hot glue or super glue. Well, I've got a lot of hot glue at home. It's cheap, and it's also the easiest to use. It's not going to get my fingers stuck together, and if I want to pull something off, put it back on, it's much easier. It's not going to rip pieces apart. It is heavier, but that's the only downside I see versus the super glue, which is lighter, but it's difficult to use. Dihedral versus anhedral, you're going to get a lot more stability out of dihedral. It's almost just going to balance itself when it, might hit bumps or this and that. It's also got more clearance at the ground, so when the little glider comes in to land, the wings aren't going to be the first thing to hit the ground. Anhedral would be great. If I wanted like a little remote control plane and wanted to do tricks and everything, but that's not what this is about. This is about being able to throw a glider, take your hands off it, and let it do its thing and see how far you can get it to go. So dihedral was obvious. Materials were given. The balsa wood was what I used. The only thing that wasn't given was the hot glue. But wing placement, I've got the center of gravity on the quarter cord, which is what I found in research and in this class to be the best available way to do it. Tail configuration, just went with a straight vertical, one straight vertical stabilizer, and then the one straight horizontal stabilizer. So sizing, I found in research that the fuselage should be about 75% the length of the wingspan. The wingspan is 16 inches and the fuselage is 12, so that's pretty exact. I also found that the horizontal stabilizer should be 25 to 30% the area of the wings, and that's what it ended up being. The wing area is 24 square inches, and the horizontal stabilizer was about 7 square inches, which is 29%. So I'm happy with that number. The vertical stabilizer is supposed to be at 10 to 15% of the wing area. Again, the wing area is 24, and the vertical is 3.5, which is about 12.5%. So that's pretty good. And the wings were tapered, like a middle taper, so tapered on the leading edge and trailing edge. It was 2-inch at the root, 1-inch at the tip, which is good because it gave it a strong base where it attached, and and give it a nice high aspect ratio while not making the tip so small that it'll just fracture if it hits the ground. This was my second iteration. Originally I had a fuselage that was 12 inches and an 8-inch wingspan. Basically everything was cut in half. It was just half the size of my final iteration. And everything worked out actually pretty well on that. I just wanted to try that one first in case it wasn't working out. The only problem with that is I misaligned the wings on one side, so it was diving off to the side a bit. But so obviously I corrected that with the final one. The way I calculated the lift coefficient, the drag coefficient is shown here. Just use the ambient density at sea level, the weight, velocity squared, divided by the area of one side of the wing. Took that number over, brought it over to the drag, and then doubled the induced drag to get the total drag coefficient. On the left, you can see the picture of my glider. That piece of balsa wood is 16 inches, and then the rulers are set to 16 inches. And then it's my first try there, went about 25 feet, and then on the second try on the right, I put a few grams of Play-Doh on the nose of the plane to get it to about 58, 60 feet. In summary, I would have tested it out, or I wish I would have tested it out outside before the day came to do it. I'd just been testing it inside in the halls, so the wind played a factor on that day. It would have made the fuselage longer. I think it would have helped with the pitch stability. Also, I would have put more weight on the front right from the get-go.